Now I introduce a Markov decision process. A Markov decision process is playing a very important role in reinforcement learning and control theory. However, its idea is simple. It's a five tuple. Behind the tuple are an agent and his environment. The first one, S, is a current state of agent. A is action taken by an agent. T is state transition probability from a current state to next state. R is a reward from the environment. A Markov decision process uses a dynamic programming method to solve the optimization problems and finally find the optimal policy. Let's say we have a state S0, S1, S2, S3. At each state, agent may take different actions, A1, A0, A3, and so on. At each state, agent takes an action, and the environment response to agent's action gives a reward. And then agent moves from from his current state to the next state with a different probability. So different state with different probability. For example, go from 1 to state S2 with 0.3 probability. Okay? For example, for same action, 0.4 probability to S1, 0.1 probability to S0, and 0.02 back to his original state. If environment is known, then it's easier for Markov decision to select action and move to the next state and receive a maximum reward. If environment is dynamic, so it's much difficulty for agent to select action to receive a maximum reward. However, if environment is unknown, then agent have to learn his environment to build a system model or the state transition probability. And then based on that generated probability or state model, then can use reinforcement learning method find the optimal action to receive move from one state to another and receive a maximum reward. A Markov decision process is based on Markov property. Markov property is generally speaking, when we predict that about next state, it is related to all the previous state and actions. However, to simplify the Markov decision process, in most of the practical problems, so we can remove the contribution from the previous contribution from the previous state and the previous action. We only use the current state and the current action to predict the next state. So in this way, we can make a Markov decision process much simpler. For more details, please check with the reference. Thank you. Bye.